Our next speaker is Dr Rory Monaghan, Lecturer of Energy Engineering in the School of Engineering at the National University of Ireland, Galway. He is the lead of the Energy Research Centre in NUI Galway Ryan Institute, a funded investigator in MARI, the Science, Medicine and Research Centre for Energy, Climate and Marine, and the Director of the Energy Engineering Programme at NUI Galway. Rory has been researching hydrogen and fuel cells since 2003, when he commenced his graduate studies at the Massachusetts Institute of Technology. Rory currently leads the long-term effects work package of the €9.3 million GenCom project, which is funded by the EU Interreg Northwest Europe programme. He was commissioned by the Department of the Economy in Northern Ireland to prepare the think piece for the hydrogen opportunities in Northern Ireland. Rory, that's probably one of the best introductions I've ever given you, and it's over.
Thanks very much, Paul, and thanks to the teams from Seafuel, GenCom and Huge for organising this event. I've been really enjoying it so far. So I'm going to talk to you about the Community Hydrogen Forum and focus a bit on one of the tools that the forum is offering, called the Decision Support Tool. Okay, so I'm not going to rehash this. I think our other speakers, particularly those from the communities where these projects are actually being deployed, can say much better than I can about why communities are moving towards hydrogen. But needless to say, I agree with them. And what we're attempting to do with our Community Hydrogen Forum is improve the flow of information. I really found the survey at the beginning quite instructive, that access and information were way out ahead in terms of the barriers to hydrogen rollout. So this is what we're presenting here should be viewed through that lens of increasing access, increasing information. So what is the Community Hydrogen Forum? Well, it's primarily a web portal, but it's also an information centre that's administered by the three projects that we're talking about today. So I'm a member of the GenCom project, and we have teamed up with Seafuel and Huge and have developed this. Essentially, Paul described it as the on-ramp to the hydrogen highway, and that's a really good description. I wish we had that on our website. Maybe we'll have to go back and do that. But we try to give a number of different access points for information on hydrogen, coming from the very introductory for those that are just beginning to build their understanding of hydrogen, to the more advanced, those that are ready to get projects off the ground. So it's a platform to help people understand the opportunities for hydrogen technologies in Europe. It's a forum for all the different stakeholders that you could find in a region. And by rolling the Community Hydrogen Forum out to GenCom, Seafuel and Huge, we're encouraging everyone in our project areas to get involved. So these are our objectives. It's all about awareness. It's about sharing information, keeping people up to date. This is everything in hydrogen right now is moving incredibly fast. New technologies are coming online. The cost of renewable electricity is dropping all the time, and that is a huge driver for the cost of hydrogen. It's providing it provides access to the decision support tool, which I'll go into some detail about, and it's here to assist in the development of long-term strategies. So I'm going to bring you on a quick tour of the Community Hydrogen Forum website. So I am just sharing my screen now. So hopefully, okay, that looks good. So communityh2.eu is our website. This is our homepage here. We've got some options along the top that I'll go through in a moment, and we've got some quick links that we can go into. So we can learn about what the Community Hydrogen Forum is, how it was formed. It was born originally out of the GenCom project as one of the key deliverables. But as we say, we have formed links with these other community hydrogen projects, Seafuel and Huge, and have expanded our reach, and we believe made our forum all the better for it. Hydrogen information is the starting off point for most people on this website. So we've got some hydrogen insights, which is, if you like, the introductory information that can be provided on hydrogen. we have got a discussion forum, which is a key resource, and you can see some of the more recent discussion forums that have been going on here. This is where you can go in, you can create your own forum, you can start asking questions. We have in the hundreds of members of the Community Hydrogen Forum now. So in order to access this forum, you do need to create a free login to get access to the forum, and once you're in, you can get access to other aspects of the Community Hydrogen Forum as well. One that's of particular interest is our case studies, and these have been excellent because these have really come through our partnerships with Seafuel and Huge. So we can go to the Orkney project, we can download some of the case study information, Aberdeen, and we're adding more case studies as they become available to us. So this is something where you can learn from communities that have been deploying hydrogen technologies in the real world. There's a page of useful sectoral links here. So these are some of the hydrogen associations across our various regions of Europe. Links to not just our own hydrogen projects, but to other projects across the board in Europe, and links to the partner organizations that are involved in each of the projects. In terms then of the decision support tool, this is where I just want to spend a little bit of time. First of all, showing you how it looks, and then showing you how it works and what it does. So we've got two routes into the decision support tool, or the DST as we call it, the full decision support tool and the DST simple. So DST simple, as the name suggests, is a first point of contact for stakeholders to understand their own region's energy situation, their own region's hydrogen potential. So in the first instance, this is developed for the Northwest Europe region, but we are expanding it out to the other regions of the projects. So you can learn primary energy consumption. This is just for the example of Belgium. You can learn about our renewable supplies. So we can click into Ireland here. We can look at primary energy consumption, and we can leave comments, and we can have further interactions with the various members of the Community Hydrogen Forum. So if we go into the full decision support tool, this is where we've got more information contained. We've got a little explainer here, and I'll go through this text in a slightly more graphical form in my presentation. But what we have on the Community Hydrogen Forum is essentially a map of our project areas, and we have information points. So first thing is we can click on some of these waste signs. This gives us some information on biomass resources in the different regions. Why are we interested in biomass and biogas? Well, this is a potential route for hydrogen production. So you can learn about the different countries' availability of biogas resources. We can learn about potential costs. We can learn about feed-in tariffs in each of the countries. We can also learn about the outputs of the decision support tool. So there's quite a bit of information here, and I'm going to jump back to my slides to further explain what I mean by the outputs of the decision support tool. On the map as well. Oh, sorry, that's the same thing. So I'm going to go back to my presentation and explain to you what the decision support tool is. But one thing that I just want to leave you with is that we have got, in this site, we've got links, we've got data for the largest cities in Europe, and I'm going to explain to you now how we connect the community to these cities and potential end uses for hydrogen. Okay, so, okay, I just can't see my slides right now. This might help. Just having a bit of trouble getting back into my slides here.
Joanna, do you want to set the slides up? We can take it from this side, or if needs be.
Yeah, I can't see them right now.
No problem. Joanna, can you set the slides back up again, please? And then we'll go to the jump off point that Roy was at.
Great.
Thank you, Rory. Might need to pass over control.
Brilliant. That's great, Joanna. Thank you. Okay, I've got tumbling slides. I think I did that by mistake. This should be okay. Right. So we've just done a brief tour of the Community Hydrogen Forum. What is the decision support tool? Well, in our decision support tool, we have got we first got our background material for the Community Hydrogen Forum. The decision support tool is really how you start to take the next steps. So we're assuming that someone who's come as far as using the decision support tool thinks that hydrogen might make an impact in their community. The decision support tool tries to paint a picture for how that impact could be, or how that impact could play out. So it attempts to demonstrate the role of hydrogen that is produced at wind farms among the communities, with also with battery backup and with PV arrays, and it sees how that hydrogen can be used in decarbonising city bus fleets. So this is something that I just want to explain. Why do we use the presence of city bus fleets, or the decarbonisation of city bus fleets, to demonstrate hydrogen's potential at a community scale? Well, right now, developing demands for hydrogen is probably the most pressing topic in terms of rolling out the technology. And the most, I'm probably talking over, yes, I'm talking over myself here. The most developed market right now for hydrogen demand is city buses. That's the most developed market outside of the petrochemicals in industry, is city buses. There's city buses being rolled out, running on hydrogen across Europe. These are two projects that started at the end of 2020 on the island of Ireland. So the Dublin single-decker Caetano trial and the ongoing Wrightbus trial, which is linked to the GenCom project. So what we try to do is make a realistic first route to market for hydrogen that can be produced in communities. So there's a number of levels that we do this at. So we've got the simplified decision support tool, which just gives a very, very brief overview of national energy pictures. Then the decision support tool, which I'm going to talk about now, brings us down to the national, regional, and city level. And it does this in terms of three routes. It describes in a qualitative way what can be done with biomass and hydrogen. The reason we don't go into quantitative detail on biomass is that, as I'm about to show you, there are a huge number of routes for biomass hydrogen interactions, and accounting for all of these in this forum, we just judged it to be too clunky and it would not be particularly user-friendly. What we do have is detailed analysis of wind hydrogen production schemes, and then integrating that wind with solar and battery storage to see how that can further improve hydrogen production. So I went through this. This was a backup slide just in case I couldn't get access to the website. So this outlines the connections between biomass and hydrogen. So as you can see, there's a number of routes, and the primary determinant of which route one would take on a biomass to hydrogen pathway is what type of biomass do you have available to you. So to put it simply, the more moisture rich your available biomass resource is, spreading coming all the way from slurries and organic wastes, the more suited that feedstock is to biological conversion. The drier the feedstock is, closer to wood and to demolition waste and construction waste, we'd be looking at thermochemical production, thermochemical processing. Oils are put through the biodiesel pathway, and then with further processing, hydrogen can be produced as an end product. But what I want to talk about mostly is how our decision support tool for wind and solar works. So it's a map-based tool, and what we have done is we've assessed the actual energy demand for bus fleets in Europe's large cities. So we are saying that these communities can become not energy customers from large centralized energy infrastructure, but they're now going to be the energy suppliers for bus fleets in the population centers. So we can calculate a hydrogen energy equivalent for each city's bus fleet. We've got the locations of those cities, and we also can plug in the locations of all the wind farms in the regions of Europe that we're dealing with. These wind farms, there's over 4,000 wind farms in this part of Europe, and we have been able to gather statistics on those wind farms and look at things like their sizes, their annual production, and their level of curtailment. Curtailment is an important route for hydrogen production because it is potentially wasted electricity, it's potentially cheap electricity, and it can provide a baseline from which we can start to produce hydrogen. But we would also want to be topping up that hydrogen production with additional sources of electricity. And an additional source of electricity that we develop in this model is the use of solar power. So we say if at these wind farms we install solar arrays, and if at these wind farms we install battery arrays, how can different sizes of wind farms, different wind regimes, different sizes of solar arrays, and different sizes of batteries interact to produce optimal priced hydrogen? When we put all of these together in our map-based tool, we can come up with hydrogen production costs and hydrogen transportation costs to get from our distributed production sites to our centralized end-use sites. This is some of the details of how we do it. We calculate, as I said, we bring in some of the statistics for each of the wind farms in each of the regions. We come up with total available wind curtailment. We can then calculate hydrogen production and perform an optimization process to size the electrolyzer. From this, we can calculate capital expenditure, operational expenditure, and because we have our mapping tool brought in here, we can calculate transportation distance and come up with a full operating cost relative to diesel city buses. We then add a solar module to this and a battery sizing module, and we're able to perform a full optimization of hydrogen production costs with, as I said, wind in different regimes, different sizes of solar arrays, and different sizes of battery. And when we put all the results together, we thought hard about how we would present this in a digestible way. And the route that we came up with was this, as I described, the city bus decarbonisation route. So if we look at wind-only results, and we've taken here Dublin as the example, if we use only curtailed wind for production of hydrogen, we can produce about 70% of the energy required to run Dublin's bus network. If we used curtailed wind topped up with some of the wind being produced already at the wind farm, we can get that to over 100%. Now, I realize these graphics are slightly hard to see here. They're a little bit easier to see on the decision support tool. So this assesses essentially our resource size, tries to present the resource size. Down here, then, we present some estimates of costing. The grey bar here represents the cost of operating or the cost of driving a diesel bus a kilometre, and normalised to that, then we have the costs for high, medium, and low cost estimates for hydrogen-driven solutions. And we see in this case, there's between a 25% and 70% markup on the operational costs of running buses in the cities. And then we can see from a logistics point of view how far that hydrogen needs to travel from its production site in the communities to its end use site in the nearest large city. We can also then look at the same results for combined wind, PV and battery systems. And we see that there is increased hydrogen production in this case because we now have We now have solar arrays also available to produce electricity for electrolysis, and we can use batteries to smooth out the short-term fluctuations in the renewable energy resource, and that can be used to, again, optimally size an electrolyzer for hydrogen production. You see on this side, our cost estimates are much lower now. So what the addition of PV battery to wind in hydrogen production does, while it increases capital costs, it decreases the overall cost of hydrogen production, because we are able to better size our electrolyzer with the addition of lithium-ion storage to, as I said, smooth out the short-term fluctuations in energy output. So this is just a kind of an end summary of the decision support tool. It's live now. I'd encourage you to get signed up and start using it. I'm sure people who use it will have lots of questions. That's what our forum is for, and that's what we are here to do as well, is to try and guide you through that and see what the next steps for your community are. So I'll finish on this next steps. Go to comunityh2.eu, register. It's a free registration process. Learn about what's going on. Have an exploration of the DST, and then contact us to see what you want to do in terms of driving hydrogen in your community. So with that, oh, there's my backup slides. Those are there in case the web link didn't work. But with that, I'll thank you for your attention, and I'll take any questions.
Rory, thank you very much indeed. An excellent introduction, how people to get engaged. And as we started with the poll, 42% of the audience said that lack of access was the biggest barrier they had. If you look at the Community Hydrogen Forum, it's possibly reactive, and the DST. How do we now move that to the next stage so that people can be more proactive and have a return for what the work that they put in?
Well, yeah, and that's something that I think we spend a lot of time thinking of. How can we get further input from people? Well, I think now that we have the DST or the Community Hydrogen Forum in place, I hope that it will be kind of a rallying point for communities that are interested in hydrogen, and that we can use the interest of new members to improve it. So I'm hoping there's a sort of a self-reinforcing effect here, that we can that as more communities come on board, we can continue to tailor it to their demands, to what they want it to do. I think the addition of the case studies from the Huge and Seafuel projects is the beginnings of doing this, where we can see from example how other communities have started to bring hydrogen to bear for their own benefit.
There's a question from Alex Gunt. Rory says, would a community be more interested in cost competitiveness of hydrogen versus other fuels such as diesel, or capex or opex cost and payback periods?
I guess we've gone with this overall, what's termed levelized costing or life cycle costing for the project. I completely understand that that's maybe not the metric that every community would use, but essentially we had to start somewhere. We had to start with some kind of comparison, and in the initial stages, we didn't really know how much interest or how much buy-in there'd be from communities. So we tried to present this in the most generally communicable way as we could. But I completely appreciate, and I hope that we will start to learn now through community interactions, that there may be improved ways that we could communicate this information.
One final question.
This is sorry, Paul. I just wanted to say one thing on that. Yeah. This is by no means here's our decision support tool, here's our Community Hydrogen Forum, take it or leave it. We want people to engage with us, and we want communities to tell us what works best for them. And so that's maybe the overall message that I want to leave people with today.
One final question, Roy, before we go to the directors of the Interreg projects, is from Donald Walker. Making this technology commercially viable without government support is the key to driving this forward. The generation infrastructure is available apart from the electrolyzer design, which seems to make the process problematic and expensive. Are there any developments in this area?
So sorry.
This is back to your Massachusetts days, Rory.
Yeah. So sorry. Specifically on the electrolyzer. Okay. So I'm just having a look at it.
As Donald says, the generation infrastructure is available apart from electrolyzer design, which seems to make the process problematic and expensive. Yeah,
look, I guess it's electrolyzers are getting cheaper by the year. You know, if we look at what an average production cost for hydrogen is now, it's probably something in the region of €5 a kilo, something like that. I see that Nel electrolyzers have claimed that they could have fully green hydrogen produced at less than $2, maybe down as far as low as $1.50 per kilo. So the technology is improving. The main driver of the costs actually for hydrogen produced from electrolysis is the cost of electricity. So even in the absence of improvements in electrolyzer technology, as renewables get cheaper and as we get more renewables, which are continually driving the bulk cost of electricity down, hydrogen will become cheaper. But look, I fully take Donald's point that it's a big investment to get into hydrogen in the first place. And I do think the government support is needed to kind of prime the pump on that regard. I don't think that communities I don't think communities could be expected to take the first step, the first leap themselves.
Excellent. Rory, thank you very much indeed.